Hello students, today we learn about the Coulomb's law. As per the Coulomb's law state, between the 2 point charges, here the point charges is the Q1 and the Q2, there is a force F which will be the either attractive or the repulsive. Suppose both have the same charges, means both is the positive charge or maybe both are the negative charges, then there will be the force exit between two charges in such a way that force on Q1 due to the Q1 will be in this direction and force on Q2 due to the Q1 will be in this direction. Means the force is in repulsive direction, and if the charge will be the opposite, means the Q1 will be the positive and Q2 will be the negative, or we can say also Q2 will be the positive or Q1 will be the negative, then there will be the force exits between both the charges in the attractive direction. Means Q2 will be the force on Q1 in this direction and Q1 will be the force on Q2 in this direction. Statement of the Coulomb's law. Here suppose we consider that both are charges in a vacuum. And both are the positive. And distance between them is r. Then as per the Coulomb's law, this 2 point charge is very small, must be very small as compared to the distance between them. Then force act on both charges will be directly proportional to the product of the mass of the charges and inversely proportional to the square of the distance between them. If we consider the international system or SI unit, then Q will be the coulombs, R will be the meter, and the force is in Newton. Mathematically, F is directly proportional to the product of the mass of Q1 and Q2, inversely proportional to the square of the distance between them, and it is also depends on the medium. Here we use the medium as a vacuum. Suppose we use the air as a medium, then the answer will be the force will be the different as compared to the vacuum. By combining these two equations, we get the force is Q1 Q2 upon R square, force proportionally to the Q1 Q2 upon R square. Here, if we remove the proportionality, then we add the proportionally constant K. Then force F will become the F is equal to K Q1 Q2 upon R square. Newton is the unit, and the value of the K is 1 upon 4 pi epsilon 0, and the value of epsilon 0 is 8.84 cross 10 raised to minus square Coulomb square per Newton meter square. Then the force F will be the in general form written F is equal to Q1 Q2 upon 4 pi epsilon 0 R square Newton. Coulomb's law in a vector form. Suppose we have the charge Q1 which is the positive and charge Q2 which is the positive, and the distance between them is r, and we find the force on Q1 due to the Q2. That means the direction of the force is this direction. This one the for Q2 and this is the our Q1. This is our source and this will be our destination. Then distance between them will be the R2 minus R1, or we can say that R12. Okay, then force can be written force on 1 due to the Q2 charge is 1 upon 4 pi epsilon 0 Q1 Q2 upon R12 in the R12 direction. Similarly, if we require to find force on Q2 due to Q1, then it can be represented by the force on 2 due to the Q1 can be written as 1 upon 4 pi epsilon 0 Q1 Q2 upon R21 square in R12 direction. If we change the direction, then we can say that F12 is equal to minus F21. Coulomb's law in the superposition form means Coulomb's law also follow the superposition. Suppose we have the charge Q and we have the different charges Q1, Q2 and Q2, and we require to find the force on Q2 due to the different charges. Then first of all we find the individual force due to the Q1, Q2 and Q3, and then we add them. We get the final force on the charge Q. Application and limitation. To calculate force between the two charges, as we know before, to calculate the electric field due to the test charge. What is the electric field? Electric field means, suppose we have the one charge Q1 and another charge is Q2. If we move the charge Q2 around the charge Q1 and find the force at all the position, then we get the electric field due to the Q1 on Q2. To calculate force on one charge due to the multiple point charge, superposition theorem. Limitation. It can be applied to the point charge only, means we cannot find the force due to the surface or volume. They should be the stationary with each other, means both charge must be then the stationary, they are not in a motion. Okay, thank you.